This is a unit test, stoichiometry exam review. Okay. Number one, appropriate uses of a visible light spectrophotometer include which of the following? So, the you should know what is a photometer. So this one you can measure, right? Using this meter, you can measure um, the optical the optical observance of visible light by chemical components. Okay, so you can check, you can find the concentration, right? How much it absorbs the light, right? So it shows you those kind of data. So if you read the first one, the determining the concentration of the solution, yes, that's the main purpose of spectrophotometer. Measuring observance, yeah, that's how you're gonna check it, by checking that observance. Okay, those two is correct. Determining when which ions are present, that one you cannot measure it by using that um, spectrophotometer. Okay, so answer should be 1 and 2 only. Now number two, 40 milliliter sample, 0.25 molarity KOH is added to 60 milliliter of 0.15 molarity BaOH2. So what is the molar concentration? Concentration is a molarity of hydrogen ion OH minus in the resulting solution. Assume that the volume are additive. Okay, so you add this one to this one. So you need to find out then to find out concentration, you need to find out mole first. So when you multiply this one into, you need to change into liter. So you divide by 1,000, so 0.04 liter. So molarity times liter will give you mole. So you can say 0.04 liter times 0.25 molarity. Then if you use a calculator, then you're gonna get 0.01 more, okay, of KOH. Okay, so 1 KOH, right? So then that potassium hydroxide, then you're gonna have same mole of OH, right? So you can say 1 mole of KOH, then you're gonna have 1 mole of OH minus, right? So because KOH when it ionized and K plus, potassium is group 1, so plus 1 plus OH minus, right? Hydroxide ion. So 1 KOH makes 1 mole of OH minus. So then when you multiply it out, then it's just like 0.01 mole of OH, right? Now, what about the other one? So 60 milliliter by divide by 1,000, so 0.06 liter times 0.15 molarity BaOH2, right? So then when you multiply, then you're gonna get 0.009 mole of barium hydroxide. Okay, but here's the thing. So 1 mole of barium hydroxide, and then you have a 2 mole of OH ion, right? So then you have actually, so this one will be times 2. So you're gonna have 0.018 mole of hydroxide ion OH minus, right? So now, so when you add up, so this one plus this one, because you mix together, so 0.01 plus 0.018, when you add up, that's 0.028 mole of OH minus, right? Now they ask you, then what is a molarity concentration? So that means a mole divided by liter. So when you add up, 40 milliliter plus 60 milliliter is 100 milliliter. 100 milliliter is a 0.1 liter. So you divide by 0.1 liter. So will give you molarity. So which is a 0.28 molarity OH minus. So should be C. Okay. So you find out each mole of OH minus, then you add up and then you divide by the volume, the total volume, right? Now number 3, so this one 3 and 4 both refer to the dissolving magnesium chloride in water. So 200 milliliter of 0.6 molarity MgCl2 is added to 400 milliliter of distilled water. So what is the concentration? So you can simply use M1 V1 equals M2 V2. Okay, you can use this formula. You don't have to change this one into liter. So if you keep it, this volume is a milliliter, then the other one should be also milliliter. So then MgCl2, so you can say 0.6 times 200. And now what is the molarity? That's what you're looking for. It's at 400 milliliter distilled water. So when you put that in, actually, because you put water only there, so you should say then this one's 600, right? Not just 400. Because 400 plus 200 will be 600. So if it's 200, then 0.6 molarity. Now, if it's 600 milliliter, then how much molarity? So you can use a calculator and then divide by 600 that one. Then you're gonna get 0.2 molarity. Okay, so answer is A. Okay, use that formula. Now number 4, we show the following description best represent the result of dissolving magnesium chloride in water. So if you look at one by one, so actually what happened, magnesium chloride, so which is MgCl2, Mg magnesium is a 2 plus, right? Magnesium is 2 plus and then Cl is minus, so you need 2 of them. So if it's melted, if it's dissolved in the water, then what happens? So then Mg2 plus 2Cl minus. You can have it like this, right? So then in the water, so let's say around magnesium, so this is a positive charge. So you have H2O, so O is in like that, and then this is polar, so this is O and this is H plus, right? This is O2 minus. So that's H2O, it'll around it, but you're gonna have like O is closer, like that, okay? Because O is a 2 minus charge, so they are closer to that. So you can see this Mg2 plus ion is attracting partially negative O atoms, right? The oxygen atoms in water. So should be B. Okay, attracting partially negative oxygen atoms in water. So around here, like oxygen, like that. Okay, so they are positive charge and negative charge, they attract each other. Now next one, let's see. For the next 4 questions, the choices to be used are CO3 2 minus and Cl2O7 minus 2 minus, NH4 plus and then Ba2 plus and aluminum 3 plus like that. So assume that you have unknown consisting an aqueous solution of salt that contains one of the ions listed above. And in each case, which ion must be present from the sample of the basis of the following observation. Okay, the solution is a color. What I see here, most of it just like white color, but there's a like orange, right? One orange color, which is basically dichromate. So, which is Cr2, that, right? That one is dichromate, is orange color. So should it be then B, okay? The solution is color because that one is orange color. Now, number 6, the solution gives a apparent reaction with hydrochloric acid. Okay, so hydrochloric acid looks like this, like that, very strong acid. So which one react with that? Okay, so this one, so is it with carbonate ion? So this one plus carbonate ion, right? So then you're gonna have basically H2O and plus CO2, okay? With the carbonate ion, it react. Of course, to match the. So in here, this one is only H plus comes out, right? If it's ionized, then 2H plus there, and then and then one of the O is coming here, so it'll make H2O and then CO2 like that. So this one react with which one is react with HCl, then carbonate, which is A. Now number 7, the solution is always soluble. So I want to know that what is always soluble. Always soluble is sodium ion and potassium ion and lithium ion. Those are always soluble. And ammonia, right? Ion, and then nitrate ion, and this one C2H3O2. Okay, acidic, that also always soluble. So those things is always soluble. Now, the solution always soluble, then of course then C, right? So this one, ammonium ion. Now number 8, precipitate is formed when dilute solution H2SO4 is added. Which one precipitate? Precipitate is a solution. I mean it's a solid state, precipitate. So which one when you combine? So you see that here D, barium, right? Barium 2 plus SO4 2 minus. When this one comes together, then it will make precipitate. So Ba SO4 is a solid. Okay, so then that one it forms. So D. Okay, so you're gonna memorize. So that is a white crystal solid. Now next one, number 9. 8.333 molarity NaOH stock solution is to be prepared from solid sodium hydroxide. Okay, so NaOH. Now, what mass of sodium hydroxide is needed to prepare 750 milliliters of this 0.333 molarity solution? So what you have to do is first of all, so I want to know first how much. So this molarity point here 750. 70 milliliter of this molarity. So what you need to do is you change into liter first. So 0.75 liter times 0.333. Molarity means mole per liter. Okay, that's one molarity. Of course, that NaOH. So I can find out how many moles. So when you multiply, then you get 2.24975 mole of NaOH. Okay, when you multiply this one, liter cancel out. Now, so I need to know then like how many grams of, so that one. So 0.24975 more NaOH. To find out gram, you need to multiply molar mass. So 1 mole of NaOH. If you use a periodic table for to find out the molar mass of sodium hydroxide, then if you find that out, then it will be around like 40 gram. Okay, so then when you multiply it out, then very close to 9.99 something, so 10 gram NaOH. Okay, sodium hydroxide. So then should it be B is answer. Now number 10, one molarity solution that would produce the least ion in solution is what? Okay, so which one produce the least ions? Okay, so you have to first see which is most soluble, right? So we talk about that here. What kind of ion is soluble here? So Na here is 100% soluble, also Na here. And then also we know that NO3, right? Nitrate, also soluble. And then this one, H2SO4 is a very strong acid, which is very soluble, okay? Strong acid. So it ionizes like almost 100%. So then this one, acetate, okay? This one, acetate acid, is a very weak acid. This one, weak acid, so name is acetate, acetic acid. Acetic acid is very weak acid. So it's not much ionized, okay? So if you talk about what is a weak acid, then weak acid is like example, HF, and also you can say H2SO4, SO3. H2SO4 is a strong acid, but H2SO3 is weak acid. And then another one, HClO and HNO2. HNO3 is a strong acid, but HNO2 is also weak acid. So those are example of weak acid. So it's not very soluble. So that means not going to have a lot of ions, so very least ion. Now number 11, a student weighs 0.0154 mole of pure dry NaCl in order to prepare 0.154 molarity NaCl solution. So of the following pieces of equipment, which would be most essential for preparing the solution? So you want to prepare this much solution, this molarity. So what you have to do is, that much molarity. So using this mole, how many liters you're gonna have, right? So think about it. Then 0.0154 mole divided by how many liter will give you 0.154 molarity, right? So basically then that's the X is 0.1, right? 0.1. So 0.1 liter, you need to 0.1 liter, that means 100 milliliter, right? Because 1 liter is 1,000 milliliter. So you need to have 100 milliliter. So the way you need to measure is volumetric flask. Then you can measure exact. Okay, so volumetric volumetric flask, that's how you gonna measure that exact one. Okay. Now number 12, next one. Now what volume of 0.8 molarity potassium chloride stock solution is required when preparing 20 milliliter of 0.6 mole of potassium chloride solutions. Okay. So then you can use also M1, MV1 is M2V2. So you can use that. Okay. We talk about same stock solution with a different molarity. So 0.8 molarity, how much volume? So that's what you're looking for. And this on 0.6 molarity, and then you can use a 20. You don't have to change into liter. Then this one also milliliter. Then when you solve for this V1 using calculator, then you're gonna have a 15. So 15 milliliter you're gonna need. Okay. Number 13, a solution MX2 is divided into two samples. To one sample, 0.1 molarity silver nitrate, right? So silver nitrate, like that. Okay, and then is added to dropwise, and the white precipitate forms. On adding sodium carbonate, so sodium carbonate, which is Na2CO3, because CO3 is a 2 minus and Na is 1 plus, so you need to have a 2 sodium ion. And to other solution, white precipitate forms. What is the most likely identify MX? What is this MX then? So think about this. Which one precipitate forms? So anything is a soluble, then you're never gonna get precipitate. So Na is very soluble, so you're not gonna get any precipitate. Or NO3 also, we talk about it. Those are very soluble. So answer is we comes down to B or C. So if you think about it, so AG, right? In here AG, AGBR is also a white precipitate forms. Okay? And also here we make a CuCO3, right? So that's also white precipitate. So to do that, you need to have C. Okay? So AGBR and then CuCO3, those are white precipitate. And then calcium is also one of the things is soluble. Okay, calcium. So it should be C. Now let's move on. Number 14. What volume of 0.1 molarity HCl is required to neutralize 25 milliliter of 0.12 molarity barium hydroxide? Okay. So let's start from then. Barium hydroxide. When you multiply this on, right? So 0.025 liter times 0.12 molarity, they will give you how many mole. So when you multiply down, so 0.003 barium hydroxide, like that. Okay, that one times neutralize, right? So basically, let's set up the chemical equation first. So HCl plus barium hydroxide. So you're gonna have definitely water. So H2O plus then Ba. Ba is a 2 plus, so BaCl2 you're gonna have. So let's figure out the coefficient. So then you have Pa is just 1. Now if you look at O, right? So then you have this 2O, so 2 you're gonna need. And then H is a 4, then here 2, and then you're gonna need another 2, and then that makes sense because that's a Cl2. So I balanced now. So that means 1 mole of barium hydroxide, and then you're gonna need 2 more, right? Because that 1, 2, 2, 2 more of HCl. Okay, so then when you multiply, how many more of hydrogen chloride you're gonna have? So when you multiply, so then 0.006 more of HCl. Okay, now but you have a 0.1 molarity HCl, right? So what volume you're gonna have? So from here, so you can say here 0.006 more divided by some volume, right? Volume will be then molarity, 0.1 molarity HCl, right? To neutralize. So then your X value, you're gonna have when you divide by 0.1, so you have X is a 0.06, right? 0.06 then liter. Okay, so then 0.06 liter, and then that one is how many milliliter here, so times 1,000, so we'll give you then 60 milliliter, right? Answer D. So let me explain quickly one more time. So that one times that, okay? So 0.25 times 0.12, then you get 0.003 barium hydroxide ion. Now, if you set up the chemical equation, I know the ratio is 1 more barium hydroxide, you need 2 more of hydrogen chloride. So 1 to 2 more like that. So I need, I need this mole to neutralize. So 0.006 mole of HCl. Then how many milliliter you're gonna need this one? So what I did is, using this molarity, molarity is a mole over liter, right? So when you divide by 0.1, okay? So basically what I did is 0.006 mole divided by 0.1 mole per liter, okay? So then it will leave how many liters? So which is a 0.06 liter, okay? That much. But now milliliter, so you multiply 1,000, then you're gonna get 60 milliliter of HCl. Okay, that's how I'm gonna do. Now let's move on. Number 15. 1 liter of 1 molarity lead nitrate is added to 1 liter of 1 mole potassium nitrate. The concentration of the ions in the solution is what? So this one, lead 2 nitrate, so Pb is a 2 plus, so NO3 minus, and then you're gonna need 2 of this, right? So that's a Pb, lead second, and then nitrate, and potassium, which is a KNO3. Okay, so that one. So what is the concentrate ions each one? So when you add it together, your molarity not gonna stay, because actually 1 liter plus 1 liter is a 2 liter, right? So when you talk about Pb2 plus lead ion is basically, 1 molarity times 1 liter, that's 1 mole, right? So it was a 1 mole, but now when you divide by not 1 liter anymore, so 2 liter, right? Because add up 1 liter plus 1 liter is 2 liter. So you can have a 0.5 molarity. Okay, so not this one. Now, similarly, when you talk about the potassium ion, is also 1 mole, right? Now, but when you add up those 1 liter, so 2 liter, which is also 0.5 molarity of potassium. So potassium, both of them are 0.5. So all of them like that. Now then, what about NO3, right? Nitrate ion. So then nitrate ion was right here, which is basically you have a 2 mole of nitrate there. So 2 mole of nitrate, and here 1 mole of nitrate, right? From potassium nitrate, when you add up 1 mole of nitrate divided by 2 liter. So 3 mole divided by 2 liter, which is 1.5 molarity. So nitrate is 1.5, so answer should be D then. Okay, that's how you're gonna find out each molarity. Now number 16, H2SE plus blah 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 like that. And then which of the following is true regarding the reaction presented above? So let's look at the oxidation number. Okay, the way you have to do is, those things, H is H always a plus, right? So this one is, there's no plus minus sign, that means it's a neutral. Charge is 0. So that means this Se should be then 2 minus. Okay. Now here O is always a 2 minus, like that. So then in order to be neutral, so then should be also this one 2 plus. Okay. Now F normally is a -1, right? So then should be this one is a +6. So it changes. Now this also -1, and H plus is +1. O2 is a 0 in here. There's no charge. So which one is a true? Oxidation number O does not change it. That's not true, because it could be it used to be -2, but it's a 0, so that's not true. The oxidation H changes from -1. No, it's from +1. Actually, it doesn't change. So this one doesn't change at all. Oxidation number of F was usually 2 plus, but now 1 minus here. But it said 1 plus, so that's not true. So answer comes down to D. Let's see. SE was a charge was a 2 minus, but on the right hand side, this charge is a 6 plus. Yeah, that's correct. Okay, answer is D. Number 17. So they give you incomplete that chemical equation. When the equation for the half reaction above balanced with the lowest whole number coefficient, the coefficient for water is what? Okay, so you start from chromium, so Cr2. So I'm gonna say 2 chromium there, and then next you can see you have here total 7 oxygen on the left hand side. So then you're gonna need 7 here. Then you have a total 14 H here. So then 14. Okay. So that means that this is 1 here. Now this one, if you look at the oxidation state here, O is O2 minus. But you have a 7 of them, so that's a -14. But in order to be entire one is a -2, you're gonna have a 12 charge. So that means your chromium ion is a +6 charge, right? But now it's a +3 charge. It used to be +6, so that means each chromium ion lost 3 ion, but both 2 of them, so total 6 ions, 6 electrons it came out. Okay, so that's how you're gonna do now. So what is the coefficient of H2O? Is a 7. Number 18. In which of the following species does a sulfur have the same oxidation number as it does H2SO4? Okay, same oxidation number the sulfur have. So H is H1 plus, right? So then this one is a 2 minus. Okay, so now if you look at here, so then this one is a +2, So SO3 2 minus 2b2 minus O is a 2 minus, right? So times the 3, which is negative 6, but 2b2 minus S is a plus 4. Sulfur is a plus 4. Now next one, S2O3. So that means negative 2 times the 3, right? So negative 6. Negative 6. So 2b 2 minus, so it'll be, this one should be plus 4 total. So then S2 plus, right? Plus 2. This one just 2 minus. This one 0. Then which one same as then this one plus 6, right? So given one here. So H2SO4. So this one is a H is a 1 plus, right? And this one is a 2O2 minus. So that means that times 4 is a negative 8. And then this one 1 times 2 is a 2. So when you add up, that's a negative 6, right? So S should be plus 6 charge. And then which one is a plus 6 charge, right? So none of them, but except this. So let's see, that's actually plus 6 charge. So O is a 2 minus, right? Times 2 is a negative 4 charge. Cl is a negative 1. So negative 1 times 2 is a negative 2. So negative 2, negative 4 is a negative 6. So this one to be neutral should be positive 6. So answer should be 6. That's how I'm going to calculate the oxidation number. Number 19. Okay, so that's the last one for this multiple choice video. Now, which of the following is the net ionic equation for the reaction hydrofluoric acid HF and calcium hydroxide? Assume both reactants are aqueous in solution as reactants. Okay, so HF, right? Hydrofluoric acid plus CaOH2. Then of course, this one acid base. Then you're gonna have a water, H2O, right? And then CaF, right? But Ca is 2 plus, F1 minus, so CaF2 you're gonna need. So this one is a precipitate you're gonna have. Now, so in order to match the coefficient, let's see, Ca, okay, so F2 minus, so you're gonna need 2, right? And then O, you're gonna have a 2O here because of this, right? So then you're gonna need 2. So that's a total. H is a 4. Yeah, that makes sense, right? It all correct now. So then, which one is right? So this one basically, so this one, Ca2 plus 2OH minus becomes like that. So there's no spectator ion. So everything you should have it. So not like that. You should have like this on the right hand side. And then which one is correct? Then it should be this one, right? Okay. So that is a net ionic. So you have to write down ionized one. So it should be B. Okay. That's it for this video.